I want to choose the instancing workflow actually because it does illustrate the point of one of the disadvantages of having lots of modules. I mean, for example, if I wanted to instance sort of these repeating geometries over a surface, I've got several options. I've got about 4 different modules and 4 different ways to achieve this. I mean, this particular example here is set up with nucleus and end particles, and I'm instancing to the end particles. And for that, I'd have to go to the sort of nucleus tab here and control my nucleus node and go to the instancing options here. I mean, for example, if I just move one up, we'll see that the options all change and the things get shuffled around and they look a bit different there. Oh, I'm not sure why the shading has gone a bit funny. There we go. So that's the nucleus system. I can also do the same thing with MASH. So here's the MASH system, and if I double click on that, I've got a completely different interface to interact with this, and I can go into the MASH system and I can start to manipulate that. And again, it's got its own distinct, rather odd interface to deal with that. If I wasn't using, I could decide not to use MASH. I could also use XGen. XGen itself also has its own rather unique and novel interface. But if I decided not to use XGen, I could also use the new Bifrost, which also has its own unique and interesting interface. Let me just load that up for you. And you'll see here, sort of Bifrost has its own nodes and interface in order to generate, again, instance particles on a grid. So the disadvantage of using all these interesting systems is I've got 100 ways of making instances on a grid. I would have to test out each one to see its merits and if it was to do the job that I wanted to do. But the downside is none of these systems communicate with each other, or if I wanted to mix them, I'd have to set them up twice in each system using different interfaces and different methodologies. Each have got their pros and their cons, but that's something you'd have to work out and make the right decision on the job to do. Whereas in a unified sort of context in Houdini, it just makes things a lot simpler. I mean, Houdini just literally deals with points. So we'll take a grid and we'll scatter some points on there. And once we have the points, we can pretty much do anything with them. As I've mentioned before, I add some attributes. So I'm just creating a random ID attribute. Here's just making sure the ID attribute does cycle between 0, 1 and 2. And then I'm using a copy node, which is copying either a different geometry to each one of those points based upon that ID attribute. And instead of copying here, we could easily turn this on, and we can, at the moment they are in fact turned into instances or packed primitives. So, and I could just build it with the one simple system. Now the advantage of this is it doesn't need to be a grid plugging in there. We could just plug a particle system straight in, and oh, don't want to scatter to that, and we could see what happens with that. That's looking for the first input, so let's just plug a sphere in. And then if I press play, let's get some particles going first. But if I had some gravity, so let's just pop some gravity in there. And then if we look at our copy, in fact it would probably be a good idea to not to have so many particles. Let's just get rid of those. Let's just have 100 particles at the minute, and we'll stream them out along the Z, something like that. So the point is, as you saw, it's very easy. Once I've got the instancing system, was just to change the input points, and I get different instances on those. I mean, it could be that, it could be even just a pig's head that we copy in there, and we'll get instances all over the surface. Oh, that's a bit too big. So either on the actual vertices, or if we what we could do is just scatter on the surface of the pig, and then we get random ones all over the surface of the pig there. That'll be a bit easier to see. There we go. So the advantage is, once we've done that, we can build basically plug in any system that we like, and we can see the results pretty much instantly. Oh, happening there. Oh, there we go. That's why. Not such a easy thing to do in Maya. You'd have to sort of build a different system, or if you wanted to change stuff, you'd have to rebuild the system from scratch again. So again, illustrating the advantage of having a unified sort of context that deals with everything, and it just makes the flow of the data and the points and stuff through the system a lot simpler, and enabling us to then just get access to that to do pretty much whatever we want to do on those points. So just a little recap there. So the Houdini contexts, they allow us to easily partition the various jobs of the particular pipeline, you know, modeling, texturing, simulation, that kind of thing. And within those contexts, they have their own unique nodes, which keeps things a little simpler once you're in those contexts. And the nice thing about it is we can easily reference data from the different contexts, create interesting effects, because we can easily send data between those various parts of Houdini. And the advantage of this is it keeps your networks relatively easy to read and set up with fairly logical flow. So you have one network for your surface, your modeling, another network for your simulation, another network for the result of that simulation, etc. It keeps things a little bit more compartmentalized and easy to understand. Let's pop into sort of quite another major part of Houdini and Maya, obviously, and that's texturing. So we'll look at that in the next chapter.